So long. A lot going on here at the school. Okay, so I'm going to go over each of the questions from the homework and walk you through those in case you had any concerns. So this was from page 175. Okay, so the first one asks for you to draw a tree diagram to show the sample space for the coin in the spinner. And then here, what's the probability of getting heads in combination of a hat or a coat. So we're going to start with the tree diagram. So again, I always like to do the one with the fewest outcomes first, which would be the coin. We have heads and tails. Event 2 is going to be our second one, which is a spinner. Okay, and then I list each of those, and this one's going to be hat, coat, pants, and shirt. So those combinations are possible with heads. So I could flip a coin, it would land on heads, and I could spin a spinner and get each of those. I could also flip the coin and get tails, and then also get those same options on the spinner. So again, I have to repeat those there. So then you would list the outcomes. Okay, and so then you'd have a hat and heads and a hat, heads and a coat, heads and pants, heads and shirt, tails and a hat, tails coat, tails pants, and tails shirt. So those are all the possible outcomes then. So then part B here says, what's the probability of getting heads in combination with a hat or a coat? So that means I'm looking for heads and hat and heads and coat. So there's one, there's two. It's the only time that occurs. So then I would write probability heads with hat or coat equals, and it happened 2 times. My total possible outcomes is all of this here, which is 10 of them. So it would be 2 over 10. Again, we like to reduce that. Divide by 2 gives me 1/5. Then as a ratio 1 to 5. And then as a percent, 1 out of 5 is 20% chance of getting this. Okay, so again, doing a tree diagram is a great way to show all those possible outcomes. All those combinations easily shows them. Okay, so the next one. Joey randomly picks a marble from a bag containing 1 red, 1 green, 1 yellow, 1 purple, 1 black marble. And then he spins a spinner with 5 equal sections, 1, 2, 3, 4, 5. So create a table for these. Okay, so my 2 outcomes. So again, on a table, you're going to do event 1. And on this one, sure, let's do the spinner. Okay, now remember on this, it doesn't matter which you put where. Event 2, marbles. And typically it doesn't matter which one is event 1 and which one's event 2 unless it specifically tells you what to do. Okay, so here I'm going to put all the spinners, and the spinners' possible outcomes were 1, 2, 3, 4, and 5. Okay, and then the marbles, if I look back here, what were they? Red, green, yellow, purple, black. So red, green, yellow, purple, and black. Okay, so there's all those. You can tidy that up a little bit. So I'm going to finish all my boxes for my table here. And now all I have left is to do the combination. So I can have a red and a 1. I can grab a green marble. Oops. I can grab a green marble and spin a 1, a yellow marble, spin a 1, purple marble, spin a 1, and a black marble and spin a 1. Okay, so again, we're just going to fill all these in here. Okay, there we go. So there our tables complete. Okay, so now we have some questions here. So this one, B, says, what's the probability of choosing a green marble and spinning a 1? So we look back at our thing here. How often does that occur? Green and 1 occurs 1 time. So we would say 1 over how many outcomes are possible in this total table? 5 along this side, 5 along this side is 25 total. 5 times 5. So we have 1 to 25, 1 to 25, and that would be 4%. C, probability of getting a yellow with a 2 or a 3. Okay, so how many times does that occur? So I need to get rid of this. That's going to get rid of a lot of things. Okay, how many times is yellow? So down the yellow column here, 2 and 3, 1, 2. So it's only twice. 2 out of 25, 2 to 25, and that would be 8%. D, what's the probability of selecting a green marble and spinning a number less than 3? So green and less than 3, or we could put 1 or 2, since those are the only options available. So there's 2 of those, because that would be green, 1, and 2. 2 out of 25, 2 to 25, 8%. Okay, so that's how we do question 8. Hope you're sticking with me here. Keep following along so you understand these. All right, number 9. Greta flips a nickel, rolls a 6-sided die, draw a table. Okay, so we're going to have a 6-sided die. 1, 2, 3, 4, 5, 6. That was terrible placement, but whatever. Okay, heads, tails. Now we're just going to fill this in. Okay, now I need to label it. So event, this time I'm going to put event 2 up here. And the die. And then event 1. And the, what is it, coin. Okay, again, it doesn't matter which side you put it on. Just put it on A side, and away you go. Okay, B says, what's probability of giving heads and 6? Heads and 6 only occurs once in our table. So probability heads 6 is going to be 1 time, because that's the favorable one. How many total outcomes? We have 6 on this side, 2 on this side, so that means we have 12 total. 12. 1 to 12. And I believe that is 8%. Okay, that's B. C, what's the probability of having the nickel land tails and rolling a number larger than 2? Okay, so this one, tails, and greater than 2 equal. So how many are greater than 2 on tails? 1, 2, 3, 4. 4 over 12, which reduces to 1/3, 1 to 3, 33%. Okay. Those ones are fairly basic, fairly easy. We're gonna step it up a little bit here. Okay, number 5, and these ones are on page. These are the ones on 381, I believe. Murray spins a spinner and rolls a 4-sided die. Once again, they want a table. Holy, the tables. Okay, so we're gonna do spinner is event 1. Okay, and on the spinner we have evening. We have morning, and we have afternoon. Okay, and then on the die, event 2, we have, let me put that across there, we have eat, sleep, what else do we have? Play, and work. Okay, finish off our table here. All right, so we can eat, evening, eat, morning, eat, afternoon. Sleep in the evening, sleep in the morning, and sleep in the afternoon. Play in the evening, play in the morning, play in the afternoon, or work in the evening, work in the morning, or work in the afternoon. Okay, so there's my table. event 1, event 2 are there. For B, probability of sleeping in the morning. Okay, sleeping in the morning only happens there one time, so it'll be 1 out of how many? 3 in event 1, 4 in event 2. That means 12, 3 times 4. So 1 to 12, 8%. C, probability of eat or play in the afternoon. Okay, eat afternoon there, play afternoon there. So this time it's 2 out of 12, which reduces to 1 over 6. 1, 6. Okay, which is percent-wise is 17% rounded up. Okay. Hopefully there's no questions about that one. Okay, now these next two are a little bit more difficult. So important you pay attention on these ones. Okay, so this one, 2 darts are thrown and land randomly on the dartboard. Draw a table to organize the outcomes. Okay, so in this one, event 1, this is the most common mistake with probability in grade 7, is getting these type of questions right. So 2 darts are thrown and land. So event 1 is going to be throw number 1. Okay, and what's possible on throw number 1? All of this is possible. So across on our table, you're going to have 2, 3, 3. Oops, I missed a 2. See, look at me making mistakes already. 3, 3, and 5. Okay, so those are what's possible on the table. Okay, throw number 1, I could get any of those things. So what's event number 2? Event number 2 is throw 2. So what's possible in throw number 2? Those same things again. I can get a 2, I can score a 2, I can score a 3, I can score a 3, and I can score a 5. Okay, so this is the most common mistake here. Often we see people will put the 2, 2, 3, 3, 5 along the top, and then over here they'll have throw number 1 and throw number 2. Okay, or spin number 1 or spin number 2 or whatever it is. Please do not do that, because that means you could get a throw number 1 and a 2. You can't score a throw number 1 or score a throw number 2. Okay, though remember, we always check and make sure the outcomes that we say are possible are actually possible. For example, I can score a 2 on my first throw and a 2 on my second throw. Again, so there are 2 possible times you can hit 2 on the first one. Same thing, I can score a 2 on my first throw and a 3. Score a 3 on my first throw and score a 2. 2 and 5. Okay, I can do a 2 and a 2, a 2 and a 2, 2 and a 3, 2 and a 3, 2 and a 5. 3 and a 2, 3 and a 2, 3 and a 3, 3 and a 3. That's going to finish this off here. Five and 2, 5 and 2, 5 and 3. Okay, so there's our table. So these are all the possible combinations. So there's 25 of those total. 5 in event 1, 5 in event 2. Okay, so now it says part B. What's probability the score will be the same for each throw? Okay, so what they're getting at there is in throw number 1 I get a 2, and throw number 2 I get a 2. Those scores are the same. So what's the probability that the 2 scores, or the 2 numbers in the boxes, will match? Okay, so on this one, match, 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 and match. So there's 4, 8, 9 of those. Okay, so on that one, we would put probability scores match. And that would be 9 out of 25. 9 to 25, and that would be 36%. Okay, the next question said, C, what's the probability the sum of the 2 numbers will be more than 5? Okay, so probability sum greater than 5. Okay, so sum again is an addition, the answer to an addition question. So we're going to add together the numbers inside the boxes. So that one's 4. 4 is not greater than 5. 5 is not greater than 5. 7 is greater than 5. Okay, this is 5, 5, 4, 4, 5, 5, 6, 6, 8, 8, 10, 8, 6, 6, 8, 7, 7, 5, 5. Okay, so what do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now I would have 13 out of the 25 are greater than 5 sums. Okay, and so this is going to be like 52% or something. 13 divided by 25. Yeah, 52. Sorry, 52%. 13 to 25. Okay, so that's that question. Again, this is the most important. You see, when they're doing something twice, one time they do it, the other time they do it. So we're going to see something similar here. So this one says the following spinner is spun twice. Okay, so event 1 is the first spin. Whee! Event 2, they spin it again. So this one says, so this one doesn't even ask you for a table or a tree diagram. But I always, even if it doesn't ask me for one, I do it. So throw, sorry, not throw, spin 1, spin 2. So it's possible on spin 1, 1, 3, 5, and 7. So on spin 2, 1, 3, 5, 7, 1, 3, 5, 7, 1, 3, 5, 7, 1, 3, 5, and 7. Okay, so those are all the things that are the possible combinations here. Let me draw my lines here. Okay, so then I have my outcomes. You can see why this is important in a minute. So 1 and 1, 1 and 3, 1 and 5, 1 and 7, 3 and 1, 3 and 3. Okay, so now I look at the question. It says, A, what's the probability that the sum of the numbers is even? So next I'm going to do another column, and it's going to say sum. Okay, what's the sum of that? 2, 4, 6, 8. 4, 6, 8, 10. I'm seeing a trend here. 6, 8, 10, 12. 8, 10, 12, 14. So for B, probability sum even, all of them. So how many are there? 4 times 4 is 16. So 16 out of 16, which we could say is 1 to 1. We could reduce that to 1, and that would be 100%. So no matter what you spin, your two spins, the sum of them added together is going to be even. So the next one says B, probability of the product is even. So product, even. Okay, again, it's out of 16. So now I could do product column. Okay, so I'm done with this column here. I'm going to worry about this column. So 1 times 1 is 1. 1 times 3 is 3. 1 times 5 is 5. 7. 3 times 1 is 3. 3 times 3 is 9. 15, 21. 5, 15, 25, 35. 7 times 1 is 7. 21, 35, 49. Probability that it's even. I don't see any even numbers there. So 0 out of 16. 0%. Okay, and then we have one more go here. So that's how we do that one. So that's the product. Product is the answer to a multiplication problem. Next one says, what's probability that the positive difference between the two numbers is 2? So positive difference, meaning we're going to get answers that are positive, not negative. So it's going to depend which direction we subtract these. Okay, so positive difference is 2 equals 2. Okay, so 1 subtract 1 is 0. This one again, so you're going to go 3 subtract 1 is 2. 5 subtract 1 is 4. and 7 subtract 1 is 6. Okay, now we're going to go 3 subtract 1 is 2, 3 subtract 3 is 0, 5 subtract 3 is 2, 7 subtract 4 is, or 3 is 4. 5 subtract 1 is 4, 5 subtract 3 is 2, 5 subtract 5 is 0. Now we switch it so it's 7 subtract 5, and that's 2. Again, this is an example. Positive difference. If I went 5 subtract 7, that would give me negative 2. That's not a positive difference. So I go 7 subtract 5, changing the order there. Okay, so now we have 7 subtract 1 is 6, 7 subtract 3 is 4, 7 subtract 5 is 2, and 7 subtract 7 is 0. So now I look for the 2's. 1, 2, 3, 4, 5, 6. So this one is going to be possibility positive diff equals 2 equals, what was that? 1, 2, 3, 4, 5, 6 out of 16, which we can reduce to divided by 2. Each of them is going to be 3/8, okay, which is 38% rounded, 3 to 8. Okay, so that's that one. So again, the key in these is looking for if it's spun twice and then knowing what those two events are. Okay, hopefully that covers it. If you need to watch it over again, watch those ones again, especially these last couple. Okay, those are the tricky ones. But remembering what each of these words mean: product, sum, difference. Okay, getting our events properly done. That's what we're shooting for here. Okay, that's the end of the homework questions. Stay tuned for more stuff on Google Classroom.